These oilseed sunflower seeds hit the soil somewhere between mid-April and late May. When the ground finally warms up enough to care about their existence, farmers space each seed about 6 to 12 inches apart in neat rows. Because apparently, even plants need their personal space to thrive properly here. The soil temperature needs to reach at least 45 degrees Fahrenheit before anything happens. Otherwise, these seeds just sit there, judging your impatience quietly. Within 11 days, those little black seeds crack open and push through the dirt, announcing their arrival, like tiny green flags, claiming agricultural territory everywhere. Baby sunflower seedlings emerge with 2 cotyledon leaves first, looking adorably vulnerable before they start their ambitious journey toward becoming 6-foot-tall giants eventually. The growing sunflowers need exactly 1 inch of water per week. Not more. Not less. Because these plants apparently miss the memo about flexibility. Nitrogen and potassium fertilizers get side-dressed along the rows when plants develop several true leaves, feeding their inevitable transformation into agricultural skyscrapers across the field. Weeds try their best to compete for nutrients and moisture, but farmers fight back with cultivators and herbicides like it's some kind of vegetable warfare. The sunflower plants shoot upward rapidly, producing large, rough leaves that feel like sandpaper, reaching heights between 5 and 7 feet in just 3 months. Around 33 days after emergence, the flower buds finally become visible at the top, promising the spectacular yellow show that's coming soon enough here. Young sunflower heads track the sun across the sky every single day in a phenomenon called heliotropism, because these flowers are basically solar panel stalkers. The bright yellow petals burst open in midsummer, revealing hundreds of tiny disc flowers packed together in the center, like nature's most efficient geometric puzzle. Each sunflower head contains anywhere from 1,000 to 2,000 individual disc flowers, and every single one will eventually become a precious, oily seed. Bees visit the blooming flowers occasionally, even though sunflowers are self-pollinating, because apparently the insects just enjoy being extra helpful and social around here. The flowering period lasts about 30 to 45 days, painting entire fields in brilliant yellow that photographers and Instagram users find absolutely irresistible every summer. After pollination finishes, the yellow petals drop away and the heads gradually turn downward, as if the sunflowers suddenly got shy about all the attention. Seeds develop and mature over the next 30 days, plumping up with oil content that reaches 40 to 50%, which is impressively fatty for something. The entire plant starts dying back, turning from vibrant green to brown, because sunflowers believe in dramatic exits rather than subtle seasonal transitions here. The back of each flower head transforms from green to yellow to brown, signaling to farmers that harvest time is approaching and patience is finally rewarded. When seed moisture drops from 35% down to 9 to 12%, these sunflowers are officially ready for their mechanical harvest date. Finally, some farmers spray desiccants on the plants to accelerate maturity by about a week, because waiting for nature's timeline apparently isn't profitable enough anymore. Specialized combine harvesters roll through the brown fields like hungry mechanical beasts, cutting stalks and separating seeds from dried heads with ruthless mechanical efficiency throughout. The combines use sunflower-specific headers that guide the heavy heads into the machine, because regular equipment just isn't fancy or specialized enough for this job. Seeds pour into the combine's grain tank like a black waterfall, representing months of sunshine and photosynthesis now concentrated into tiny, oily packages efficiently. Stalk crushers pulverize the remaining plant material back into the soil, returning nutrients and organic matter while clearing the field for next year's crop rotation. Grain trucks haul thousands of pounds of seeds away from the fields during golden hour harvest light, heading toward processing facilities that never actually sleep. At the processing plant, harvested seeds first pass over powerful magnets that grab any metal traces, because apparently farming equipment occasionally loses small parts everywhere. Cleaning sieves shake and vibrate vigorously, separating dirt, broken seeds, stones, and other field debris from the valuable oilseed sunflower kernels, moving through continuously. Destining equipment uses air jets and density differences to remove heavier rocks and lighter chaff, leaving only the perfect black seeds worth processing further. Industrial dryers blast warm air through the cleaned seeds for several hours, reducing moisture content from 12% down to exactly 5% optimal. The seeds tumble inside massive rotating drums heated to precise temperatures, releasing steam clouds as thousands of pounds dry simultaneously in controlled mechanical chaos. Properly dried seeds flow smoothly toward the dehulling machines, where mechanical violence will soon separate the hard outer shells from precious inner kernels waiting. Braking drums spin rapidly with metal rosettes and padded pallets that crack open each seed with calibrated impact force, releasing kernels from protective hulls efficiently. Pneumatic airstreams blow the lighter hulls away, while heavier kernels drop through screening systems, creating two separate material streams from one original seed. Some facilities remove 100% of hulls, while others only remove 50%, depending on the desired protein content in leftover meal later. The naked golden kernels move toward grinding equipment, about to be transformed from discrete seeds into a coarse meal with dramatically increased surface area. Hammer mills and grooved rollers crush the dehulled kernels into uniform particles, breaking down cellular structures to release the oil trapped inside each tiny cell. The ground meal gets heated to temperatures between 140 and 180 degrees Fahrenheit, conditioning it for maximum oil extraction efficiency. Steam rises from the warm meal as natural oils begin glistening on the particle surfaces, signaling that everything is ready for the pressing stage. The conditioned meal feeds continuously into screw press machines, where rotating metal screws generate several tons of pressure per square inch, relentlessly crushing everything. Golden crude oil starts flowing from the press like liquid sunshine, while flattened, compressed cakes emerge from the other end looking like dense brown hockey pucks. This mechanical pressing extracts about 50 to 75% of available oil, which sounds impressive until you realize there's still plenty left behind stubbornly. The pressed oil collects in stainless steel tanks below, looking dark and cloudy with suspended particles. Nothing like the clear, refined product you'd recognize. Meanwhile, those compressed cakes aren't finished yet, because hexane solvent extraction will squeeze out every last drop of oil that mechanical pressing somehow missed. Workers pour food-grade hexane solvent over the pressed cakes in sealed extraction towers, where chemistry does what brute mechanical force simply couldn't accomplish. The hexane molecules dissolve and absorb residual oil from the cake, creating an oil-solvent mixture called micella that looks pale and slightly concerning, honestly. This solvent extraction recovers the remaining 25 to 50% of oil, reducing the final meal's oil content to less than 1%. Technically, after extraction, the hexane must be completely removed from both the oil and the meal, because nobody wants petroleum products in their cooking oil, obviously. Steam stripping columns heat the micella, causing hexane to evaporate while crude oil remains behind, with vapor condensing for reuse in a satisfyingly efficient loop. The desolventized meal gets toasted and dried, transforming into protein-rich sunflower meal containing 28 to 42% protein for animal feed production. Now the crude oil begins its multi-stage refining journey, transforming from dark, cloudy liquid into the crystal-clear golden oil that grocery store shoppers expect. First stop is degumming, where the crude oil gets heated to temperatures between 185 and 200 degrees Fahrenheit in mixing tanks. Hot water or acidified water gets added to the heated oil, causing phosphatides and gummy substances to precipitate out like unwanted party crashers. Suddenly, high-speed centrifuges spin the mixture at thousands of rotations per minute, using centrifugal force to separate the heavy gums from lighter oil efficiently. The degummed oil moves to neutralization tanks, where sodium hydroxide solution gets mixed in, creating a chemical reaction that neutralizes free fatty acids immediately. This alkali treatment forms soap stock that settles out with other impurities, leaving behind oil with improved color, odor, and stability for further processing. Next comes bleaching, where the oil meets activated clay or activated carbon that acts like a molecular sponge, absorbing pigments and oxidation products efficiently. The mixture gets heated under vacuum while the adsorbent materials grab onto colored compounds, trace metals, and remaining phospholipids with chemical enthusiasm and precision. Filtration removes the spent bleaching clay, now saturated with captured impurities, revealing oil that's visibly lighter in color than what entered the tanks minutes ago. The oil transforms from dark amber to pale golden yellow during this stage, losing its characteristic sunflower color but gaining the neutral appearance refiners want. Deodorization comes next, arguably the most dramatic transformation in the entire refining process, where flavor and odor compounds finally meet their ultimate doom. The bleached oil enters tall vacuum deodorizer towers, where temperatures soar to 425 to 482 degrees Fahrenheit under extreme vacuum. Live steam gets injected through the superheated oil, causing volatile flavor compounds and odor molecules to evaporate and escape into collection systems above immediately. 1% citric acid gets added to chelate trace metals that might promote oxidation, extending the shelf life from months to years if stored properly. What emerges is completely neutral, odorless, almost flavorless refined sunflower oil that would be unrecognizable to the original plant that produced the seeds months ago. Some producers include an optional winterization step, slowly chilling the oil to 45 degrees Fahrenheit to crystallize and remove natural waxes that cloud. These wax crystals get filtered out, ensuring the final product stays perfectly clear even when stored in your refrigerator, which apparently matters to some people. Quality control technicians test the refined oil for color, clarity, free fatty acid content, peroxide value, and taste. Because standards exist for a reason. The approved oil flows toward the bottling line, where automated systems wait to portion this golden liquid into consumer-sized containers at lightning mechanical speed. Clean bottles march along conveyor belts in perfect formation like little glass soldiers, heading toward filling nozzles that dispense precisely measured volumes every time. Automated filling machines inject the crystal-clear pale yellow oil into each bottle with accuracy measured in milliliters. Because nobody wants to shortchange paying customers. Caps get screwed on tight by mechanical arms moving so fast they blur, sealing freshness inside while preventing oxidation from ruining months of work. Colorful labels wrap around each bottle showing sunflower images, nutritional facts, and cooking suggestions, transforming industrial output into recognizable retail products. Customers trust. Bottles get grouped together, shrink-wrapped into multi-packs, and loaded into cardboard shipping boxes, ready for their journey to warehouses and grocery store shelves. Quality inspectors randomly pull bottles from the line for final checks. Because even automated systems occasionally make mistakes that need human eyes to catch. Forklifts stack completed pallets in the warehouse, each one holding hundreds of bottles, representing acres of sunflower fields and months of agricultural patience finally. From a tiny black seed planted in spring soil to refined cooking oil in your kitchen pantry. This journey takes about 6 months total. The sunflower meal byproduct heads to animal feed manufacturers, where it becomes protein-rich nutrition for cattle, pigs, and poultry on farms everywhere nearby. Discarded hulls get repurposed as biomass fuel or low-grade animal feed. Because the modern food industry wastes absolutely nothing if profit margins allow. Soap stock from the neutralization process becomes raw material for actual soap production or gets processed into animal feed additives, completing the utilization circle. Even the recovered hexane solvent gets recycled and reused hundreds of times, making the extraction process surprisingly environmentally efficient. Despite using petroleum-derived chemicals weirdly, the entire industrial operation runs 24 hours daily during harvest season, processing thousands of tons of seeds into millions of gallons of cooking oil. Modern processing plants can handle 300,000 tons of sunflower seeds annually, which sounds impossible until you see the scale of equipment involved. Workers in hairnets and food safety gear monitor computer screens showing temperature, pressure, and flow rates. Because oil production is now more science than art. The refined sunflower oil has a high smoke point around 450 degrees Fahrenheit, making it perfect for frying without breaking down into unhealthy compounds. It's also rich in vitamin E, linoleic acid, and polyunsaturated fats, which nutritionists consider the healthy kind. Unlike those saturated troublemakers everyone avoids. Chefs love sunflower oil's neutral flavor that doesn't overpower delicate dishes. Unlike olive oil, which insists on making its presence known in everything annoyingly, home cooks appreciate that it doesn't solidify in the refrigerator like some oils do, staying liquid and pourable even when stored in cold conditions. The global sunflower oil market processes over 50 million metric tons of seeds annually, with Ukraine and Russia producing nearly half the world's supply. Each sunflower plant produces just one large head containing up to 2,000 seeds, which means millions of plants died to fill your grocery store's oil aisle. From the farmer planting seeds in spring sunshine to you drizzling golden oil over tonight's salad, countless hands and machines contributed to this journey. The price of sunflower oil fluctuates based on weather, politics, fuel costs, and global demand. Because apparently everything in agriculture eventually becomes complicated economics. Organic sunflower oil production follows the same basic process but uses natural refining methods and avoids synthetic pesticides during the growing season. Costing more, obviously. Cold-pressed sunflower oil skips the hexane extraction and high-heat refining, preserving more nutrients and flavor, but extracting significantly less oil from each seed. Industrial refiners prefer the efficiency of chemical extraction and high-heat processing, prioritizing yield and shelf life over preserving every last vitamin molecule carefully. Storage facilities keep finished oil in temperature-controlled environments to prevent oxidation, because rancid oil tastes terrible and nobody wants that reputation or liability. Trucks deliver pallets of bottled sunflower oil to distribution centers where they sit briefly before continuing to thousands of retail stores across entire continents. Finally, the bottles reach grocery store shelves where they wait patiently for shoppers to grab them, continuing their journey to home kitchens and restaurant fryers. That seemingly simple bottle of sunflower oil represents approximately 120 days of plant growth plus weeks of industrial processing, packaging, and distribution logistics. Next time you pour sunflower oil into a pan, remember those golden fields? Massive machinery and complex chemistry that transformed sunshine into liquid gold.